Okay, so U-substitution is one of these things that we need a lot of practice with, and they're just fun integrals that we need to be able to solve, basically. So we're going to practice a lot of different types, and I want to go through some of the weirder ones. So we're going to make up an integral, and we're going to say the integral is sine squared of 3x times cosine of 3x dx. When I look at this integral, I know right away I can't do any of the memorized trig rules because of this sine squared. And I know I can't use power rule. So with those options kind of out of the way, I pretty much know I need to use U substitution, or at least give it a try and see if it works. So we're going to go through our steps here. The first step is we got to let U equal something. And that's kind of what I want to figure out first. Before I let U equal something, I'm going to rewrite this problem. Sine squared 3x, if you think about it, sine squared 3x is really, I'll put a little thought bubble here, it's the sine of 3x quantity squared. That's what it really is, the sine of 3x quantity squared. So in reality, this integral, in my mind, is more like this. It's the sine of 3x all squared times the cosine of 3x dx. And the reason I'm rewriting it is because it's going to kind of drive what I decide to make my u. I'm gonna let u equal the sine of 3x. That's that entire inside piece here, right here. So this piece is going to be my u. Okay, so that's step one, figure out the u. Step two is derive, du dx. So the derivative of sine 3x requires the chain rule. Derivative of 3x is 3, sine is cosine, and we keep the inside 3x. Okay, then I'm going to multiply dx to the other side and get du equals 3 cosine of 3x dx. And if you look at your problem, this is almost perfect because we have a cosine 3x dx right here. That's exactly what I was going for. I don't need this extra 3. There's no extra 3 in this problem. So I'm going to divide the 3 away to the other side. And I'm basically going to rewrite this. I'm going to write du over 3 equals cosine of 3x dx. And if you look at the problem up above, this whole thing, cosine 3x dx, this is really du over 3 when I substitute. So now that I've gotten that figured out, my next step is rewrite the integral in terms of all u's. We've got to get rid of the x's completely. So I have a u here, but it's still squared. So u squared. All the extra junk in the problem is now du over 3. So u squared times du over 3. And if you take that over 3 and you pull it out as like a 1/3 in front of the integral, this is really not that bad of an integral anymore. It was terrible at the start. It was a really hard one, but now it's just u squared. So I'm going to reverse power rule. U squared becomes u to the 3rd power over 3. Add 1 and divide. And then I have a 1/3 in front. I have a plus c because there's no bounds on my integral. And 3 times 3 is 9. So I have u to the 3rd over 9 plus c, which really is mostly a good answer, but I started with x's, so I should end the problem with x's. So I don't really want to leave it like this. I'm going to change my u back. And remember what u was? U was the sine of 3x. Sine of 3x cubed plus c, and then over 9. Technically you're done. That's the right answer, but because it's a trig problem and I'm trying to use like good notation, you might move the cubed portion back here. You might write it like sine cubed of 3x over 9 plus c. Or you could put a 1/9 in front. It's really the same thing, but I'm going to say that is my answer. I'm going to leave it like that. So kind of some tricky U substitution problems. This one's just a weird trig one. Let's look at another one. Let's try another one here. If you want, you could try this one. You could pause the video and try it yourself. see if you're getting the hang of this, and then unpause the video, kind of check yourself. Okay, so we're going to do a fraction, 2x cubed plus 1 over the square root of x to the 4th plus 2x dx. Definitely probably going to be a U-substitution problem. I can't power rule it, and I can't think of how to break this up any other way. So I'm going to let U equal something as my first step. And just looking at this, my initial instinct is to use this bottom piece right here. Let's let U be x to the 4th plus 2x. Next step is to derive. So I'm going to get du dx equals 4x to the 3rd plus 2. Okay. Then I'm going to multiply my dx over. So I'm going to get du equals 4x to the 3rd plus 2 times, whole thing times dx. Then you go back and you try and rewrite your integral. If you go back and you take a good look, we have a 2x cubed plus 1 dx. That's our extra stuff. And I don't really want a 4x cubed plus 2. So to fix that, it's an easy solution. Let's factor a 2 out of all of this and divide the 2 over to the other side. So du over 2 equals, if you divide a 2 out, you get 2x cubed plus 1 times dx. And this is perfect. That means all the extra stuff in that integral, all of this, is really du over 2. So rewrite this. After going through these steps, rewrite this integral so that the fraction is still there. The whole top of the fraction, all of this, is du over 2. And the whole bottom, there was a square root down here. We changed that to a u, so it's a square root of u. And now I can solve this. I'm going to pull the 1/2 out. So I'm going to have 1/2 integral. I'm going to make this 1 over the square root of u du. Seems a little better that way. I'm going to change this to be u to the negative 1/2 power, integral of u to the negative 1/2 power du, with a 1/2 in front. And then it's reverse power. We'll add 1 and divide. If I add 1 on, we're going to have u to the positive 1/2 divided by 1/2 times the 1/2 out in front plus c, because we have no bounds. And so now I just got to clean this up a little bit, cancel the 1/2s, change it back to square root u, since it was 1/2 power, plus c. And then because I don't want u's for my answer, maybe go in and change the u into what it was originally, x to the 4th plus 2x plus c. And that is my answer. Alright, so a couple of things I want to look at here. Let's try one more. I kind of want to keep practicing these. So another integral, and this time I'm going to change it up a little bit. I'm going to make it a fraction, but it's going to look like this. 2x over 3 quantity x squared plus 3 to the 2/3 power dx. You should pause the video. You should try it. You should see if you can guess the u, find the derivative, and rewrite the integral. Now, if you've paused the video, maybe you did, maybe you didn't, but this is what you're going to do. You're going to let u equal something. In this case, I'm going to pick this x squared plus 3, this piece right here, and have that be my u. So let u equal x squared plus 3. Then find du dx, the derivative. Du dx is going to be the derivative with the power rule. It's a 2x. And then multiply dx to the other side and get du equals 2x dx. And then go up and look at your problem. Notice we've got a 2x dx right here. So that's good. All of that is equal to du. So that's really good. So let's rewrite this integral. New integral. We've still got a fraction. All of the top stuff is du. In the bottom, you notice there's a 3 here. We didn't do anything with the 3. It didn't come up in the problem anywhere. So there's still a 3. But the 2/3 power, the quantity of 2/3 power is now u to the 2/3 power. And that's the integral we're going to try and solve. So to solve the integral, I see a 1/3 kind of embedded in this problem. So I'm going to pull out the 1/3. I'm going to change this to u to the negative 2/3 power. Get rid of that fraction. So du is going to be over on the side here. I'm going to reverse the power rule by adding 1 and dividing. So I'm going to have 1/3 from out in front. Add 1 to negative 2/3, it's going to be u to the 1/3 divided by 1/3 plus c. And then this isn't too bad to solve. The 1/3s are going to cancel. And we're going to get u to the 1/3 plus c. So change it back, make it back to x's. So x squared plus 3 to the 1/3 power plus c. And we're going to say that is the answer. So we just got lots and lots of these that we can practice and kind of see how to do them. Just remember that when you look at an integral, you kind of have to think through, like, can you power rule it? Can you use trig rules? If all those options don't work for you, then you go to this method. So it's kind of your backup to all the other plans. And you got to be careful and pick the right u. It can be a little bit tricky. So let's practice one more for the video, and then I think we're good. The more examples you see, the better you get. So again, here's your problem. We're going to say 3 quantity 3x squared plus x to the 4th, 3x squared plus x to the 4th, all to the 3rd power times 6x plus 4x cubed dx. Pretty ugly integral. Pause the video, try it, see if you can get these right. Make yourself practice a little bit. Okay, here's my steps. I'm going to let u equal something. So I look at this problem and I think that maybe this piece would be a great thing to use for u. I'm going to give it a try. If it doesn't work, you end up going back and trying over again. But I'm going to try it. 3x squared plus x to the 4th. My derivative is du dx. So to derive this thing as the power rule, it'll be 6x plus 4x cubed. And notice that's in our problem. When you're going to pick your u, after you've done this for a while, you're going to see an integral and kind of spot like a potential u right away. Like I kind of saw this and thought to myself, oh, the derivative is 6x. Oh, there's a 6x over here. So it kind of helped me pick that out. You just get better and better at that after a while. So you multiply the dx over. Du equals 6x plus 4x cubed times dx. Then you go up to the problem and you notice that all the extra stuff hanging off the end here, all of this matches this. So this is my du, and I'm ready to rewrite the integral. If you think about it, this rewritten integral is now, it's still got this 3. Nothing happened to the 3, so the 3 is still there. But all of this is u, so u to the 3rd power, and all the other stuff is du. There shouldn't be any x's left on the problem. So to reverse the power rule is going to be quite easy. We have the 3, and then u to the 3rd is going to become u to the 4th over 4 plus c. And we're going to change the u back, so we're going to have 3 times 3x squared plus x to the 4th, all to the 4th power over 4 plus c. And as messy as that is, that seems like a good enough answer. I'm going to leave it like that. There we go. So the only way to get better at these is honestly practice, practice, practice. So make problems up, find problems, see if you can do this over and over again. You just get better and better at them. Hope that helps. Thanks.